Hi, Assalamualaikum. Today we would like to present about analyze other type of semiconductor. It is photodiode. We from Group A, and my name is Rosa Yuni binti Idris, and my number battery is 33DI19F1039.
Uh, Morning. My name is Muhammad Faiz bin Ahmad Daud. Number metric is 33 DEI 19F1037.
For the first is symbol of the photodiode. A photodiode is a semiconductor PN junction device that converts light into an electrical current. This is the symbol of photodiode. Is anode and cathode. So, it basically work in reverse bias condition. This is the structure photodiodes. It is radiation and silicon coating, P region and N region. This is anode and cathode. For the PN junction of the device placed inside a glass material to allow the light energy to pass through it. It is only the junction exposed to radiation because the other portion of the glass material is bent black or is metallic. The overall unit is very small dimension, nearly about 2.5 millimeter, to allow current flowing through the device. It is in microampere and is measured through an emitter. For the working of photodiode is the operation. So, let's understand the operation of photodiode. In my previous slide of photodiode, that when reverse bias potential is applied to a diode, then only minority current will flow through the device, and this current is known as reverse current. So initially, when the junction is not exposed to any type of radiation, then only minority current will flow through the device, and this current is known as dark current. So the name itself is indicating guys that dark current flow through the device in the absence of any types of radiation. The movement of minority carriers across the junction the minority carriers for the P side is an electron. Is and minority carrier for the inside of hole. The movement of these minority carriers across the junction will generate reverse current, a small reverse dark current. So the P junction will go to the N and the electron to go to P. After certain point of the time movement of minority carriers generate development region across the junction. This is our development region. This devolution region contains neutral atom that does not allow any fusion flow of electron or hole across the junction. Now, at this particular time, we provide radiation to the junction, or we can say the junction is illuminated with the light. So at this particular time, now as the radiation falls on the surface on the junction, the temperature of the junction increase with the increase in the temperature electron, and holes start separating from each other at the time of separation. The hole present in the region and get attract toward the negative potential of the battery, and the electron and the electron and the electron region will get attracted toward the positive potential of the battery. So due to this movement, or we can say due to this whole process that happens over here, allow the flow of current to take place, and with the increase in the intensity of radiation, the current through the device also increase. More simply, we can say that the current through the device is directly proportional to the intensity of light. Now, guys, let's move further to the next slide.
Okay, for after that, three terminals of the photodiode. Photodiode operates in three different modes. They are first, photovoltaic, second, photoconductive, and the last one is a valence diode. Okay, next, for the advantage and disadvantage for the photodiode. First, for the advantage is it shows a quick response when exposed to light. And second, photodiode offers high operational speed. And the last one is it is a low cost device. For the disadvantage, it is a temperature dependent device and shows poor temperature stability. Second, when low illumination is provided, then amplification is necessary. Okay, these are VI characteristic curve of photodiode. We have the reverse current. Okay, next, explanation VI characteristic of the photodiode. First, vertical line represents the reverse current flowing through the device. And the second, horizontal line represents the reverse bias potential. Okay, third, first curve represents the dark current that generates due to monority carriers in the absence of light. And the last one, the curve shows almost equal spacing in between them because current proportionally increase with the luminous flux. Next, the application. Photodiode are used as photo detectors. Second, used in safety electronics like fire and smoke detectors. And the last one, photodiodes are used in consumer electronics like EV units. This is a picture of photodiode. Okay, the last one is reference.
So that's all of our presentation. Thank you.
Thank you.